Then comes ASME options. These are about the nozzle options. This is about the ASME options. So ASME code addition. Can you see it over here? ASME code addition. What is the current addition of the code that we are using? 23, right? So you can see over here, current means the one which is available. So 23 is available, so that becomes current addition. So if I click upon current, it will automatically use it 2023 edition, right? Then what was the older editions? It will show you the 5 older editions. So 2021, 19, 17, 15 and 13. Correct? So for designing any latest vessel, we have to click upon the current option. Use pre-99 addenda. ASME section division 1 only. Pre-99 means what? To 1999 and before, if any addenda you are going to use, you have to click upon this checkbox. We don't have to, right? By default, for any of our calculations, we don't have to. Then use division 1. If I click upon this, then it will use the addenda before to this 1999. Use division 1 appendix 46. So appendix 46 is the appendix where it is been given. You can use a division 2 equations as per part 4 and allowable stresses as per division 1. So here you can see division 1 allowables using division 2 part 4 equations. Please do remember ASME sectional division 1 equations, whatever we are using, those are capable till the pressure value of 3000 psi, close to 206 bar. Okay. But if you want to design if you want to design an equipment which is having higher pressure than 3000 psi, so you can use this particular mandatory appendix 46, where you are using rules from division 2 but the allowable stresses from division 1. So just for the sake of calculation, to demonstrate this to you, so this is as per ASME sectional division 1. But if you want to do the calculations as per mandatory appendix or as per the appendix 46, and now I am going to perform the calculations. Now you can see that the equation what they are going to use is not as per UG 27. That will be as per part 4. And use the allowable stresses as per division 1. Can you see now? Section 4.3.3.1. This is from division 2. It is R in bracket. R means 0.5 times of D. Exponential P upon AC minus 1. So this is the equation taken from where? Division 2. So now it is using mandatory appendix 46. ASME code case 2286. This was included as mandatory appendix 46. Okay. So if you click upon this, this is a code case which allows to use alternative allowable compressive stresses and external pressure calculations, much like division 2. So the options which are disabled, don't click upon that. Okay. Then use metric ASME material database. All of you are aware that we are having two material databases. ASME section 2 part D comes in two versions, metric and customary. Can you see over here? This is in metric, right? The other one comes in customary. So here all the allowable stress values what you are going to see, that will be in MPa. That will be in, let me just open few of them for you, let's say. Similarly, if you are using customary units, the allowable stress is in PSI, pound per square inch. So if you are using metric database, always click upon this checkbox. So can you see over here what is the allowable stress value? 137.9. Correct? But if you go to metric database, it will show you 180, 138 MPa, not 137.9. The software, if you haven't clicked upon that checkbox, automatically take the allowable stress values from customary units and then convert that to the metric. Are you getting? Let's say 20,000 psi is what they have chosen and then divided it by 145 to convert it to MPa. So this will come in approximation. Whereas in metric database, they haven't used these values as 137.9. They have used it as 138. So let's see what value has been given in the table 2a. Let's say our material is 51670. What is the material? Table 2a, line number is what? 45, right? So let's say here, line number 45. What is the allowable stress value? 138. So what value we supposed to be using? 138, right? But the software is showing what? 137.9, which is not correct. So that's the reason why we have to get into ASME options and click upon metric material database. What has been written over here? To complete this change, you must access the material database for each material on each element and detail defined thus far. This process will update the material properties to what is contained in the correct material database for the current selection. So if you just change that, it will not automatically change the material over here. So first we have to click upon this checkbox always and then we have to build the model. Otherwise it will not automatically change it. Are you getting me? Now I have to reselect the material. Now I have to reselect the material so that the change will be applicable. Here our design code. Can you see over here design code? Let's say our design code is ASME section and division 1. 515, 51670 is what we are interested in, right? Now can you see allowable stress value? So what we need to do, we have to click upon this checkbox, right? Use metric ASME material database always if you are going to use the metric database. And then you should start the modeling, right? Otherwise we can have to reselect all the materials every time. Now, by default, current database means what? ASME section 2 part D metric version 2023 is what it is going to use. Then comes the remaining options. 21, 19, 17, 15, 13 and the remaining material databases you can choose from. So if you want to do the designing for some older version of the code, that is possible by selecting the material database from here. Can you see this option? Use the value of MAWP to compute the MDMT. Select to ensure that the vessel MAWP is used in calculation of MDMT. Always click upon this checkbox. Because in the nameplate you need to mention MDMT at MAWP. Do not use nozzle MDMT interpretations. So don't click upon this. Reduce the MDMT due to lower membrane stress. Click upon this checkbox. UCA 66.1 ratios below 35, 0.35 compute the MDMTs for. These are by default. Click upon this because these are the options from the code you must be knowing, right? What is UCA 68C? MDMTs can be less than minus 55 degree Fahrenheit. Consider longitudinal stress when the computing MDMTs. So right now, whatever the options has been shown over here, click on these options in your, click on OK.